Today in this video, I will explaining about retaining wall. A retaining wall is a structure designed and constructed to resist the lateral pressure of soil when there is a desired change in ground elevation that exceeds the angle of repose of the soil. However, the term is most often used to refer a cantilever retaining wall which is freestanding without lateral support at its top. There are basically two types of retaining wall. This one is cantilever retaining wall and counterfort retaining wall. I has drawn both the diagrammatic representation of the cantilever retaining wall and counterfort retaining wall. Now basically we are going to start cantilever retaining wall. First thing is why the cantilever retaining wall is used. According to diagrammatic representation, we can use the cantilever retaining wall. The reason is that the height up to only 5.5 meter or equal to 5.5 meter. We can use cantilever retaining wall. If the height is more than 5.5 meter, then we can go for the cantilever retaining wall. This is the diagrammatic representation of the cantilever retaining wall. In this part is stem part, then heel slab. This portion is toe slab. This is depth of the foundation. This one is we going to consider height. The retaining wall are used to retain the earth fill or any other material, so the ground surface and different elevations are maintained on either side of the cantilever retaining wall. This is one of the example I will be discussing about design a cantilever retaining wall. Design a cantilever retaining wall to retain an earth embankment with a horizontal top 4 meter above ground level. This h is equal to 4 meter. The unit weight of earth is 18 kilonewton per meter cube. That is, density of earth is 18 kilonewton per meter cube. Angle of internal friction, angle of repose, that is equal to 30 degree. The SPC of soil can be taken as 140 kilonewton per meter square and the coefficient of friction between soil and concrete is 0.5. Adopt M20 grade concrete and Fe415 steel. Draw the following to a suitable scale. First one is section of the retaining wall. Second one is reinforcement details at the inner force of the stem. Here this is overall height of the cantilever retaining wall. These are all given data. In this given data, safe bearing capacity, that is nothing but SBC of soil, that is given P is equal to 140 kilonewton per meter square. Density of soil 18 kilonewton per meter cube. Angle of repose 30 degree. Internal friction of coefficient value 0.5. Fy, that is equal to 415 Newton per mm square, FCK 20 Newton per mm square. In step 1, just find outing data is minimum depth of foundation. This minimum depth of foundation we have find out using Ranking's theory. According to Ranking's theory, for find outing depth value, D is equal to, using formula is P by gamma of 1 minus sin phi divided by 1 plus sin phi whole square, or minimum depth, that is equal to 1 meter. Then D is equal to, just we have substitute all given data, that P value is given 140, density of earth is 18, 1 minus sin 30 degree phi value 1 plus sin 30 degree whole square. When we calculate all those things, we are going to get D is equal to 0.86 meter. According to the rule, the minimum depth has to be provided is 1 meter. Hence, taking D is equal to 1 meter, because whatever value we are going to get, that is less than D value. D value less than 1 meter, that is D value is 0.86. Here minimum value we are going to provide it, that is D is equal to 1 meter. Here note, if D is given, then use that value. The D value is given directly in that question, just we have used that value. Then total height of retaining wall we have find out here. In that total height of retaining wall, H value is given. Here H is equal to how much? 4 meter. 4 meter is given. Then here we going to find out what? Depth of foundation. Depth of foundation, how much we going to get? Depth of foundation we going to get 1 meter. Then here we going to find out total height of the cantilever retaining wall. That is nothing but capital H value we going to find out. That capital H value how we going to get? Here depth of foundation value, that is 1 meter. Then height, horizontal top height, that one is given for up 4 meter. That 4 meter plus 1 meter, that become 5 meter. After that, here in this cantilever retaining wall, this one is diagrammatic representation. This depth of foundation is how much? 1 meter. Then this one is overall height is 5 meter. Below the ground level, that one is we going to call it as depth of foundation. After that, in that step 2, retaining wall dimension we going to find out. In this retaining wall dimension, considered 1 meter length. Considered 1 meter length. Length of the retaining wall, that one is 1 meter. In that first thing, stem top width 150 mm, that one is assumption data. Here stem top width means here to here. This portion we going to call it as stem top width. This stem top width, that value whatever we going to return, that is assumption data 150 mm. After we going to find out what? Base slab thickness. For find outing base slab thickness, this formula we going to use. The formula is nothing but overall height of the retaining wall divided by 12. Overall height of the retaining wall, that how much we going to get? That we going to get in 5 meter. That we have converted in terms of millimeter. For find outing base slab thickness, at the time 5 meter become 5000 mm divided by 12. At the time we going to get base slab thickness. Base slab thickness is denoted in terms of TBS. Denoted in terms of TBS, how much we going to get? 416.67 mm. Approximately we going to take down 450 mm. This 450 mm converted in terms of meter, at the time we going to get 0.45 meter. This one is what? Base slab thickness, TBS, base slab thickness, TBS value we going to get 0.45 meter. After that, now we going to find out stem height. Stem height means overall height minus TBS. Overall height is how much? 5 minus TBS, we going to get what? Stem height. Here for find outing stem height, that is we indicated in terms of Hs. Indicated in terms of Hs, that is equal to capital H minus slab thickness. Here slab thickness how much we going to get? 0.45. Hs is equal to 5 minus 0.45. Hs is equal to that is nothing but stem height, that become 4.55 meter. 4.55 meter. In this diagram, stem height we going to get Hs is equal to 4.55 meter. After find outing all those things, now we going to find out B dash, otherwise B1. Is it base slab width? B dash base slab width we going to find out. For find outing base slab width, the formula that is 0.5 H or 0.5 or 0.6 H. 0.5 H or 0.6 H. The value that should be varied between 2.5 to 3.5. Which are all values we going to take down, that is left on you. Here in this B dash, that is equal to 0.5 overall height of the retaining wall, that one is 5, otherwise 2. 0.6 overall height of the retaining wall 5. Then just we have calculate these values. 0.5 into 5, at the time we going to get 2.5, 2.6 into 5, then 3. Here just I will select higher value 3 meter, B dash value that is equal to 3 meter. In this diagram, B dash breadth of the retaining wall. How much we going to get a breadth of the retaining wall? 3 meter. Breadth of the retaining wall we going to get 3 meter. After that, here this portion we going to call it as heel slab. This portion we going to call it as toe slab. Now we going to find out toe projection. The projection, this part here to here, this part we going to call it as toe projection, this distance. Now we going to find out distance of this thing. The distance of this thing we going to call it as toe projection. For find out in toe projection, using formula is toe projection that is equal to B dash by 3 or 1 meter. B dash by 3 or 1 meter. Here just substitute a value of B dash, how much we going to get? 3 meter. Then 3 by 3 that is equal to 1 here. Otherwise we going to use 1 meter. Then just we going to take down toe projection that is equal to 1 meter. Then just mention here toe that is equal to 1 meter. After that, now we going to find out stem bottom thickness. Stem bottom thickness means this is the stem, this is top portion of the stem, this one is bottom portion of the stem. Here we going to find out stem bottom thickness. For find out in stem bottom thickness, we mention in terms of D1. Here to find out D1 value. For find out in D1 value, just we going to take down D1 that is equal to earth pressure on stem. D1 that depends on earth pressure on stem. Earth pressure on stem that is indicated in terms of Ka value. Indicated in terms of Ka value. Here in this diagram, backfill soil is there. Backfill soil is there. When backfill soil that should be placed at the time, the pressure arises like this. The pressure arises like this. When pressure that should be placed like this pressure we going to call it as active earth pressure. Active earth pressure. Here this earth pressure on stem that is indicated in terms of Ka. pH is nothing but area of triangle. pH is nothing but area of triangle. Here Ka is what? Coefficient of active earth pressure. Ka value is coefficient of active earth pressure. This Ka is equal to 1 minus sin phi divided by 1 plus sin phi. Here phi value we know that, just we have substitute corresponding phi value. Ka that is equal to 1 minus sin 30 degree divided by 1 plus sin 30 degree. We going to get Ka value. Ka that is equal to 0.33. Ka value how much we going to get? 0.33. After find out in Ka value, just we going to find out earth pressure, pH value we going to find out now. Here total pressure on the wall we going to find out, which is total pressure on the wall. Just we have observed here in this diagram, this is the stem wall, is it? Height of the stem. Height of the stem, how much we going to get? Height of the stem is 4.55. Height of the stem is 4.55. In a triangle way, the pressure is acted. The triangle way, the pressure is acted. Just we have observed here, we going to get in this way. In this way, the pressure acted like this. The pressure is acted like this. Here, the pH value placed in this place, then this one is a formula we going to use. That one is nothing but Ka density into height of the stem, because here we going to find out what? Total pressure on the wall. For find out in total pressure on the wall, just we going to find out base of the triangle. Base of the triangle we going to use the formula Ka. Ka is nothing but coefficient of active earth pressure, density of the earth, then height of the stem. Here in this triangle, area of the triangle we going to take down. For take down area, this one is base of the triangle. Ka into gamma into h is base of the triangle. We are going to find out what? Area of the triangle. For find out in area of the triangle, then which formula we are going to use? Half into base into height. Then half into base is how much? Ka into gamma into height of the stem is how much? H. Is it? Height of the stem is h. Here overall height is h is equal to 5 meter. Then this height, how we going to find out? This one is how much we going to get? 0.45. The thickness of the base slab is 0.45. Then h is equal to 5 minus 0.45. We going to get 4.55. Small h is equal to 4.55. After that, here that value we going to substitute in this formula. pH is total pressure on the wall. We going to find it using formula half into base into height. This one is base of the triangle. After that, this is half. Ka value already we going to find out 0.33. Density of earth is 18. Height of the stem is 4.55. Then once again height of the stem is 4.55. Then we going to get total pressure on the wall. pH value we going to get 61.48 kilonewton. After find out in pH value, then we find out what? Moment about section 1.1. Moment about section 1.1. After find out in moment about section 1.1 means, here this is the triangle, is it? In this place we going to find out a moment about section 1.1. Just I will going to written in terms of section 1.1. Here to find out moment about section 1.1 means, moment is nothing but how we going to find out moment? Moment is force into perpendicular distance, is it? Force into perpendicular distance. In force place, which concept is there? Force is nothing but total pressure on the wall, pH value, total pressure on the wall, and perpendicular distance, total pressure on the wall, that one is pH. Perpendicular distance, this one is just you remember that total pressure where it should be acted? Center of the triangle. Total pressure that should be acted center of the triangle. Then just we going to take down, that is up to which point? Base of that triangle, up to base of the triangle. This one is maximum end of the triangle, maximum intensity of triangle. This one is what? Zero intensity of triangle. The force into maximum intensity of the triangle, how much distance we going to consider? Which formula we going to use? Are you remember? Whatever we going to take down triangle, this one is zero intensity of the triangle, this one is maximum intensity of the triangle. The force that should be acted center of the triangle means zero intensity to center of the triangle. The value we going to take down 2/3 into base of the triangle. Then maximum intensity to center of the triangle, the value we going to take down 1/3 into base of the triangle. Same thing we have used here also. Here the base of the triangle means this one is we going to take down. Height of the triangle is how much? 4.5. Then we going to use this one is maximum intensity of the triangle up to mid portion. How it should be acted? 1/3 into base. 1/3 into base. Here base means this portion. No, this portion value is how much? 1/3 into 4.5. 1/3 into 4.5. And then here we going to find out moment. How we going to find out moment? M is equal to F into D. F value is pH and perpendicular distance value, how much we going to write down? 1/3 into 4.5. Now perpendicular distance up to center of this triangle, how much? 1/3 into 4.5. That one is whatever we going to find out moment about section 1.1. That one is M is equal to pH into H/3. H/3 in base place, which value is there? H is there. That's why 1/3 into base. That means in base place H is there. That's why I will written in terms of H/3. 3. Then just you substitute corresponding value, that is 61.48. pH value is 61.48. Then H value is 4.55 divided by 3. Then M value how much we going to get? M is equal to 93.2 kilonewton meter. After getting M is equal to 93.2 kilonewton meter, now we going to find out ultimate moment. For find outing ultimate moment, just we multiply 1.5. Just we multiply 1.5. Here, whatever we going to find out ultimate moment, that is nothing but factor of safety we going to multiply. Factor of safety we going to multiply. Mu that is equal to 93.2 into in terms of kilonewton meter, that is converted in terms of Newton millimeter. That's why here 10 raised to 6 into 1.5. At the time we going to get Mu is equal to 139.86 into 10 raised to 6 Newton millimeter. After that is approximately just we have considered like 140 into 10 raised to 6 Newton millimeter. Then we know that Mu is equal to Mu limit. Mu is equal to Mu limit. After that, Mu limit formula 0.138 FCK into BD square. Taking 1 meter strip here, 1 meter strip means B value that is equal to 1000 mm. Always breadth value we going to consider 1 meter strip, that is converted in terms of mm, then B is equal to 1000 mm. Just substitute corresponding values in Mu limit 139.86 into 10 raised to 6, that is equal to 0.138 into 20 into 1000 into D square. Then D value 225.10 mm. After that, now we find out total depth. Total depth means here stem bottom thickness. This value we going to find out. D1 value we going to find out. Here for find outing D1 value, D value how much we going to get? 225.10 we going to get. After that, just we going to take down D dash also. D dash is nothing but effective cover. We assume effective cover that is 50 mm. Then D1 that is equal to D value is how much? 225.2 otherwise 1. Then plus effective cover. At the time we going to get 275. Just we have considered approximately 300 mm. D1 value is how much? 300 mm. After that, provide D1 that is equal to 300 mm and effective depth that is equal to 225. Just we make out approximate value that is nothing but 230 mm. Then after that, here we going to get D1 is equal to 300 mm and effective depth D is equal to 230 mm. After done all those things, now we going to find out heel projection. Which one is toe projection is completed, D1 value is completed. Now we going to find out heel projection. For find outing heel projection, which formula we going to use? Because for find outing heel projection, overall width of the stem we know, overall width of the cantilever beam we know that, toe projection also we know, then stem width also know. Then how we going to get? In this the overall width is 3 meter. After that, toe is nothing but 1 meter. Then D1 that is nothing but 0.3 meter. Remaining thing how we going to find out? B dash minus toe minus D1. At the time how much we going to get? Heel projection that is equal to 3 meter minus 1 meter minus 0.3. Then heel projection that is equal to 1.7 meter. Heel projection how much we going to get? 1.7 meter. After that, here this is the what? Schematic diagram of cantilever retaining wall. In this schematic diagram of cantilever retaining wall, based under that concept, we have find out what? Moment of resistance. moment of resistance. Moment of resistance. For find outing moment of resistance, just we make out this column. In this column, components. Then next row, weight we mention in terms of kilonewton. Distance up to toe, here we going to consider toe is the reference point. Toe is the reference point. Then moment about toe in terms of meter, this mr is nothing but moment of resistance. Mr is nothing but moment of resistance. Here just we make out separate column, separate components. In this, how we going to make out that components in a particular shape wise. This one is what? W1 that is observe here. In this whatever I will going to take down, this one is W1. This is enclosed in a rectangular shape. Next one W2, that is in the format of triangle shape. After that W3, once again this one is in rectangle shape. Then this W4, that a weight that should be acted in backfill soil. The overall component that should be placed here. All those components included, then the thing should be we going to get cantilever retaining wall. This component weight we going to find out one by one. First, weight of the a rectangular component. For find outing weight of the rectangular component, that is which formula we going to use for rectangle? Length into breadth into height. Here just we going to take the length we will not going to get. For every 1 meter we going to get a length. That's why we going to take down breadth is 0.15. Height of the rectangle how much? 4.55. For every 1 meter means just we going to take down weight 0.15 into 4.55 into length for every 1 meter we going to consider, that's why into 1. Then this one is this cantilever retaining wall that is constructed based under concrete. That's why just we have multiply density of the concrete. How much we going to get? 25. After that, then just calculate all those things, we going to get 17.06. Next, distance up to toe. Toe where it should be placed? Here. This is a reference point. Then this weight how it should be acted? Mid of this component, is it? Mid of this component, that is then we going to take down distance mid of this component up to toe portion. How we going to take down? Here mid of this component we going to consider, that means 0.15 divided by 2. Just we have add this 0.15 plus 0.15. Then toe distance is how much? 1 meter plus 1 meter. At that time we going to get distance up to toe based under this W1 value. How much we going to get? 1.225. This one is what? Weight. This one is distance. After we going to find out what? Moment about toe. Moment means force into perpendicular distance. This force we going to consider weight also. Then perpendicular distance is nothing but, for this weight perpendicular distance is horizontal distance, is it? Here to here. Then that perpendicular distance is how much? 1.225. Then force is how much? 17.06. Here that 17.06 into 1.225 we going to get 20.899. After that, here we going to calculate which value? W1 value. After calculated this W1 value, next weight is W2 value. For find outing this W2 value, we going to get in terms of triangle. This diagram, this component, how it should be visible in terms of triangle. Next, area of the triangle, how we going to find out? Which formula we going to use for find outing area of triangle? Half into base into height of the triangle is how much? 4.55. Here half into base of the triangle is 0.15, then this height of the triangle is how much? 4.55. After that, this also included concrete, then density of the concrete is nothing but into 25. How much we going to get weight? 8.531. After getting this 8.531, now we going to find out distance up to toe in terms of meter. Distance up to toe in terms of meter. Then here this weight is acted. This weight rotated up to toe. Here rotated up to toe. This distance we going to find out. Then just we observe this one is this is the triangle, is it? This one is triangle. This is zero intensity of the triangle. This one is maximum intensity of the triangle. Weight W2 that should be acted here. Then zero intensity to center of the triangle. Which formula we going to use? Zero intensity to center of the triangle 2/3 into base. 2/3 into base. Then maximum intensity to center of the triangle 1/3 into base. Here zero intensity to center of the triangle 2/3 into base means base value is how much we going to get? 0.15. 2/3 into 0.15. Then how it should be rotated? Here in this in extended part toe is placed. Is it? Toe that is value should be 1 meter. This triangle up to this point the toe value is 1 meter. Then how we going to consider this perpendicular distance? Perpendicular distance we going to consider this is 2/3 into 0.15. That means 2/3 into base. 2/3 into 0.15 plus 1. Plus 1. Just you observe here. 1 plus, that means toe value 1 plus 2/3 into 0.15. How much we going to get? 1.100. Then just we have multiply force into perpendicular distance. At the time we going to get which value? Moment value. Force value is how much? 8.531. Then perpendicular distance value 1.1. How much we going to get? 9.383. After that, now we going to find out which value? W3 value. In this W3 value where it should be acted? In this part. This one is W3 value. Here once again we going to get a rectangular portion. For find outing W3 value, then which formula we going to use? Length into breadth into height. That one is length of whatever. Length means every 1 meter. That is 1. We going to consider the length value is every 1 meter means 1. Then breadth value is how much? 3 meter. Then this 3 meter. Then after this height we going to consider the thickness of the slab. That one is how much thickness of the slab? 0.45. 0.45. Here 3 into 0.45 into 1. Then this also we going to consider constructed using concrete. Is the material we going to use during the period of construction concrete. Then we going to use density of concrete is 25. After calculating these things we going to get 33.750. After that, now we used to find out in distance up to toe. Distance up to toe means this W3 where it should be acted? Center of this slab. Center of this slab. Then how it should be rotated to reach toe? In this way. Is it? At the time how much distance that should be included? That is half of the distance of this slab. Then how we going to get? 3/2. We going to get in terms of 3/2. How much we going to get? 1.5 meter. After that just we have multiply 33.750 into 1.5, that is 50.625. After find outing these things, now we going to find out W4. W4 where it should be acted? They should be placed in backfill of the soil. Backfill of the soil. Then this W4 how it should be visible? This also visible like a rectangle shape. Then here in this breadth into height into length value is every 1 meter, then height of this backfill is 4.55, then breadth of this backfill is how much we going to get here to here, only here to here we going to fill, that is how much 1.7 into 4.55 into 1. After that backfill means soil is placed in this place, then density of soil is how much, that is given in that question 18. Here just you observe W4 value 1.7 into 4.55 into 1 into 18. Then we have calculated this thing. At that time we are going to get 139.230. After that, distance up to toe, we calculate what? Distance up to toe. Distance up to toe means here whatever the thing should be there, mid portion of this rectangle, the W4 is acted. Then this the distance how much is there? The distance is 1.7. Mid portion of that 1.7, the W4 is acted. At that time how we going to get? 1.7 divided by 2. 1.7 divided by 2. Now after that, this should be acted up to toe portion. This should be acted up to toe portion. Up to toe portion means how we going to get? Easily we going to get here overall breadth value, we know that. Overall breadth value we know that. In that overall breadth value just we have calculate. Otherwise, okay, here itself only answer is there. 1.7 after that plus 0.3 then plus 1. How much we going to get? We going to get 2.15. In this way also we calculated this value. Otherwise 3 minus 1.7 by 2. At the time we going to get same value 2.15 meter. Then just we multiply these two values. This one is force value, this one is perpendicular distance value. At that time how much we going to get? 299.345 we going to get. After calculating all those values, which are those values? W1 value, W2 value, W3 value, W4 value. Now we going to calculate algebraic sum of forces, otherwise algebraic sum of weight of the components, weight of the retaining wall. How much we going to get? 198.571 kilonewton. After that, here moment of resistance, just we add all those things, then finally we going to get 380.252 kilonewton meter. We going to get here algebraic sum of weight. After that total moment of resistance we going to get. After find outing all those things, then further design steps are there. Those design steps we discussed in next session. Thank you.